Okay. So any any questions on the homework? We all get it? Did it okay? I saw that one of you or two of you finished the quiz after I put it in, so I'll go ahead and make sure I put that back in later today. And so if you didn't get that quiz done, there were still about 7 or 8 of you that didn't get it. So make sure you get that quiz on Schoology done. It's only 3 questions. Shouldn't take you too long to do. But is there any, excuse me, any questions on the homework that I can help you with? Anything at all? Anyone's talking, I can't hear you. Anything at all I could help you with on the homework? We're good. It was trig D, right? Are you okay with the reciprocal identities? You just realize if you're finding like cosecant, you find the sine of it and then you flip it over. Or if it was secant, you find the cosine, you just flip it over. If you find a cotangent, you find the y over x, and then you reduce it and go with that. So everyone's good with that? We sure? All right, go ahead. Nobody?
Can we do from pi over 3 to cosine?
What number is this one?
It's number 2.
Okay, so on the complete the table?
Yes.
And you just want to see cosine?
Yeah.
Okay. And you want me to just go all the way across for that?
Yes, please.
Okay. So on the unit circle, this was pi over 6, pi over 4, pi over 3. That was 0. This is pi over 2. Okay, and then 5 pi over 6 is here. This is pi. Let's see what else we got. So let's just go with that. Okay, and then 3 pi over 2 is down here. Let me see what I have. I have everything. Okay. All right, so for the cosine, so you have to remember, this is 1 comma 0. This would be, if you had this triangle, you have the longer side, so root 3 over 2, comma 1/2. This is both root 2 over 2, comma root 2 over 2. This would be, if I drew this triangle, you'd have the short side as the x, so 1/2, and then root 3 over 2. And then this would be 0, 1. So if I look at cosine of 0 and 2 pi, we're looking at the x value, so that's equal to 1. Pi over 6, so pi over 6, if you had cosine of that, you would be looking at the x component, so it'd be root 3 over 2. Pi over 4, it's just root 2 over 2. You're just looking at the x component there. Pi over 3, you're looking at the x component, so it's 1/2. And these are all for cosine. Cosine of pi halves is 0 because you're looking at the x component of the point. And at pi is over here, so this is the point -1, 0. So cosine is the x value, so it's -1. And then 3 pi over 2. 3 pi over 2 is down here. So this point here is the point 0, comma -1, so that'll be 0. That's all you'd have to write. Anything else?
Thank you.
You're welcome. And if you would have your Trig E worksheet or notes out, I gave you that the other day. If you don't, just take some notes on this, but it'd be helpful for you. We are going to have a really short quiz tomorrow, and I'm going to show you exactly what is on your really short quiz. You see this front page right here? That's what's going to be on your really short quiz. Okay, so we need to make sure that we can go all the way around this. So if I have 0 degrees, that's 0 radians. If this is 90 degrees up here, that's pi over 2. Over here, that would be oops, I put those in the wrong spot, sorry. 90 degrees pi over 2. Over here, this is 180 degrees. Oh, I had it in the wrong spot, which is pi. Over here, this is 270 degrees, which is 3 pi over 2. Okay, so that's the first thing I'd go with. The next thing I'd go with is I'd realize, okay, that's going to be 1 comma 0. This is 0 comma 1. This is negative 1 comma 0. And then this is the point 0, negative 1. So does everybody feel comfortable with that? All right, so I'm going to go around. I'm just going to do the rest of the degrees as I can do it. So I have 30 degrees here, 45 degrees here, 60 degrees here, 90. Then this is 120 degrees. Excuse me, 135 degrees, 150 degrees, 180. This is then 210 degrees. This is going to be 225. This is going to be, excuse me, got a little tickle going on. 60, that's 240. And 270s down there. Then over here, we're going to have 300 degrees, 330 or 315 degrees, and 330 degrees. And then this would be back to 360, which was then 2 pi. So then you have to be able to convert those degrees. They're pretty simple. If you remember the 60, 45, and the 30, 45, and 60, you can do all of the angles. So that's first part of your quiz tomorrow. This is really what's on the front page of the quiz. Okay. The next thing I'm going to do is I'm going to figure out the radians. So I know that's pi over 6. Now, if I can't remember how to do radians, it's going to be degrees times pi over 180. Okay. So then this would be pi over 4, pi over 3, and then over 18 is 2 pi over 3, and then 135. 135, if I go through the math, it's going to be 3 pi over 4. Then 150, so 15 divided by 18. So that's going to be 5 pi over 6. Then you come down to 210. That's going to be, oops, I went the wrong thing. So 21 over 18, 3 goes into it, 7 pi over 6. Does everyone feel comfortable? This is all I'm doing. I'm just kind of doing it in my head a little bit. 225 is 5 pi over 4. $240 is 24 over 18. 24 over 18, 6 goes into both, so 4 pi over 3. 300 degrees is going to be 30 over 18. 1 2/3, so 6 goes into both. 5 pi over 3. 315. Let's see, that's going to be what's 315? Can't do it in my head, sorry. 5 goes into both, so that's 63 over 5 goes into that. Let's see, 5 goes into that 36. 3 goes into both, 21 over 12. 3 goes into both, 7 pi over 4. 7 pi over 4.
Wait, Mr. Stirrup?
Yeah.
So, we have a quiz tomorrow in class.
Yeah, just a small one.
Okay, on what again?
Exactly what I'm doing right now.
Oh, okay.
This is the identical problem almost to the T.
Okay.
So all I'm doing right now is I'm just converting everything to radians. So I'm multiplying the degrees times pi 180. So 33 over 18. So that's 11 pi. Let's see, 3 goes into it, 3 goes into that, 11 pi over 6. So I think the radians might be the hardest part of it, is just converting. Does everyone feel okay with the radians? And again, you all know on the calculator, on the TI calculators, which you can borrow ones in class if you need to, how to reduce fractions on it. It works really neat. So I'll show you tomorrow if you don't know how to do it. It's one key more and it'll do it for you. And then you just have to remember to put pi's in there. Okay, so then what we have to do is, if you think about this triangle here, this side is the longest side. This is the shorter side. Agree? So longest side is root 3 over 2. Short side's 1/2. This is the same, root 2 over 2, root 2 over 2. And then the 60, I have the short side is my x component, so that's 1/2. Long side is root 3 over 2. And then it just flip-flops. So this would be a negative 1/2 root 3 over 2. This would be negative root 2 over 2, root 2 over 2. This would be the longer side, so I get negative root 3 over 2, and then 1/2. And then this one, the 210, you have the longer side in the x position, so I get negative root 3 over 2, negative 1/2, negative root 2 over 2, negative root 2 over 2, negative root 2 over 2, and then I have negative 1/2, negative root 3 over 2. And then down here, this is going to be positive 1/2, and then negative root 3 over 2, root 2 over 2, negative root 2 over 2. And then this one, you would have root 3 over 2, negative 1/2. If you can do that, and basically the key of looking at it is, think about, is root 3 over 2 longer than 1/2? And if you can understand that that's greater than it, you should be able to do each of these problems. The 45-degree angle, it's always going to be root 2 over 2, whether it's negative or positive components. So those are just the things that you're going to be walking into. This looks identical to the quiz. Other things that you should know is if you have x comma y as any of your points, those relate to cosine comma sine, and tangent is equal to the slope because it's y over x, and y over x is the slope. So right there, my friends, right there is the quiz for tomorrow or Friday, depending upon your cohort. Okay, is there anything about what I've written up there that you're not sure about? And I will put up on the board the degree conversion of pi over 180 is how you convert degrees. You have to do the math on your own. Okay? We good?
I have a question.
Yeah.
Why so if you go around the circle in the second quarter, why are the cosines negative? Aren't supposed to be the sines negative?
think about that point. I would have to go left and then up. So if I go left, that's negative, and then up is positive. So the x value would be negative because I would have went left first and then up as a point.
Okay, thank you.
Yep. Anything else, friends? All right, let's move on. So what quadrants are the sign values positive, negative? Well, we know that all students take calculus. So sine is positive in, this is quadrant 1, 2, 3, and 4. So sine values are positive in 1 and 2. They're negative in 3 and 4. Identify the quadrant where cosine is less than 0. So this is negative. So where is cosine negative? It's negative in 2 and 3. Where is tangent positive? So tangent's positive in quadrant 1 and also in quadrant 3. And then identify where sine is positive and tangent is negative. Sine is positive, so sine's positive here and here. Tangent is negative here and here. So quadrant 2 satisfies that argument for both. Everyone feel comfortable there? May I move on? Hey, I got my first COVID vaccine on Saturday. Woohoo! I'm still alive and kicking. Although I grew a tail. I'm just kidding. I didn't really grow a tail. So don't go spreading rumors saying Stirrup's got a tail now. Though when you come to school tomorrow, I should have like a fake tail that I have hanging out. Like he said he didn't grow it, but he has one. All right. So this is the exact same thing we've done. It's there. Okay. So we want to use the unit circle to identify. So we know that cosine is the x value. So I'm going to find the radian of 2 pi over 3, which is here. And I look at the x value. So that gives me an answer of -1/2. And that's done. And then if I look for 11 pi over 6, 11 pi over 6 is right here. I want the tangent of it. Remember, tangent is y over x. So I'm going to get -1/2 over √3/2. If I take care of the reciprocal, those cancel. So I get -1 over √3. I would totally accept that answer. Some people would prefer you to rationalize it. So you'd multiply top and bottom by √3/3. You'd multiply both top and bottom by √3 and √3. But I would take the -1 over √3. That's totally fine. And the pre-calc teacher said that it was also fine. Sine of pi, well, sine's over here, and sine, you have to remember, is the y value. So sine of pi is 0, and we're done. So I would, if I were you, put this type of thing in a handy place. I'd say you might have something that you have that can take pictures. You always have it on you. I would say take a picture of that unit circle. So if you're having to do these quickly, you can refer to it. No, I won't let you use the picture on a quiz. Okay. But I would take a picture of it so you know you have it handy, you know where it's handy for you, so you can just pull it up and be like, we're going around the unit circle. There's all the degrees and all the radian amounts all the way around it. Okay. Right there, if you can do that on the quiz tomorrow, you get all the points on the quiz. And I was thinking I'll make this quiz like 400 points. Is that okay? Because it's pretty easy. The main thing to do on here, again, this is the 30, 60, 90 right triangle. You have to realize this is a long side, this is a short side. So this is the long, this is the short. If you can see that, you're going to do quite well. If you talked about this triangle here, there's your 60-degree angle. So here is your short. And so your shortest side is 1/2. Here's your longest, which is √3/2. Okay. And again, the 45-degree angle is always √2/2 for both the x and y component, whether it's positive or negative, depends upon which quadrant you're in. Can I move on? There wasn't anything else there? Nope, cool. All right. We can also use the unit circle to find angles. What angles have a cosine value of 1/2? Okay, cosine value. So cosine value is an x value, okay, and this is a positive 1/2. So you can go around the unit circle and find which has the 1/2. Okay, that's negative. That's negative. That's positive. Okay, so the ones that I'm interested in is this one and this one. So we're talking about 60 degrees, which is also pi thirds. So that's in degrees and radians. And then we also have 300 degrees, which is 5 pi over 3. And again, if you didn't have the unit circle, you know you just multiply the degree amount by pi over 180, reduce the fraction, and keep your answer in pi. And then we come down to this other one. Let's see. Let's do. Go with that. So which ones have a √3 value? So then you have to kind of think, okay, I don't have any just exact √3s, but I know that if I were to do the tangent of this, that would be that would be 1/2 over √3 over 2. Those cancel, so that gives me 1 over √3. Oh, I picked the wrong one. I want the positive. So it's got to be this one. It's got to be this one, and then it would have to be this one as well. And the reason why they both work is one is positive over positive gives me a positive answer, and negative over negative gives me a positive answer. So this would be 60 degrees, which is pi over 3 as a radian. It would also be 240 degrees, which is 4 pi over 6. Is that right? Or 4 pi over 3? And that's how I would go about doing that problem. Okay, so it's a matter of you recognizing that you're going to go y over x. So you get a fraction over fraction multiplied by the reciprocal, and it should work out. May I move on? We're good? All right. So formally written, this is, oh, okay. So cosine is the x value. So you're going to look for which x value has the positive √2 over 2. So I have two answers to this. I have 45 degrees, which is pi over 4 as a radian. And I also have 315 degrees, which is 7 pi over 4. Both of those answers are correct. If you gave it to me in degrees, great. If you gave it to me in radians, great. If you gave it to me in both, super great. Not worth more points, just shows an understanding. Okay, we have to remember that tangent is y over x. Come on, switch to blue. So y over x, so I get a -1. So this means we're talking about the 45-degree angle, where I need only one of them to be negative. So if I chose this one, I'd get a fraction over fraction, which comes out to -1. This would be a positive one. This would be a -1. So the two angles at work is 135 degrees, which is 3 pi over 4 as a radian. And then you also have 315 degrees, which is 7 pi over 4. So both of those are fine. And then the last one, sine. I know sine is the y value. So I'm looking for where I have a y value of negative. So I got a y value here of -1/2. And I have a y value here of -1/2. So I have 210 degrees, which is 7 pi over 6 as a radian. And then I also have 330 degrees, which is 11 pi over 6. So again, if you give it to me just in degrees, great. If you give it to me in radians, great. If it says find the degree amount or find the radian amount, list the appropriate one. If it just says whatever, either answer is fine with me. That. Okay, last slide. Okay, find theta if we're talking between pi halves and pi. Pi halves and pi. So we're talking about here. This is the region that we're worried about, okay? So I want to know cosine, which is an x value. Which one has a cosine, an x value there? And that would be 120 degrees, which is 2 pi over 3. Which one would give me a tangent? Remember, tangent's going to be y over x. So y over x, it's going to be one or the other. Y over x. So root 3 over 3. If I chose this one, this would give me an answer of just negative root 3. If I chose this one, that would give me the negative root 3 over 3 if I rationalized it. So we're talking about 150 degrees, which is 5 pi over 6 in radians. And then the last one, we're looking for sine. The sine, which is root 3 over 2. So you have to remember sine is a y value. Root 3 over 2 as a y value is here. So you're talking about 120 degrees, which is 2 pi over 3. Okay. So how are you going to remember the unit circle? What do I need to do for you to make you remember it? And I'm going to erase this, and I'm going to show you a couple of patterns. And one of the patterns should work for your fancy to have things known, okay? All right, so first question, is everybody okay putting the degrees all the way around the unit circle? Is anybody stuck on that? So if I gave you blanks, you could do the 30, the 45, and the 60 all the way around. Yes? Is everybody okay with finding the radian amount? If you don't have the radians memorized, are you okay with taking 30 and multiplying it by pi over 180 and reducing the fraction? Okay. Now, the big one to see, the 45-degree angle should be the easiest one to deal with. Right here. Okay, you know that this and this have to be the exact same as far as an isosceles right triangle goes. If you know that, then you know root 2 over 2 has to be the ones as a go-to. Okay, but if I picked the 30-degree angle, I'm going to go down to this one here. So that's a 30-degree angle. You know that you have a long side. It's not the hypotenuse, but it's the long side over the short side. So then you have to realize that root 3 over 2 is greater than 1/2. If you recognize that, you should be able to figure out the exact points for it each and every time. And then the last one is, this is our 60-degree triangle, our 60-degree reference angle. And just by looking at it, you realize I have a short side here and a long side here. So that's where you would decipher the x component. If I go to the right, I'm going shorter distance than I am going vertically. Okay? So that's the main thing. Other items that you might see when you're going through this unit circle, if you just can't remember my way. Okay, I'm going to start with the y component. That's 0, that's 1, root 2, root 3, 1. I count backwards. I go 0, 1, root 2, root 3, 1. And as long as you can get the first quadrant, you can get all the rest of the quadrants. And you just have to realize sometimes there'll be negative components, sometimes there'll be positive components. So that's just the ins and outs of dealing with these types of problems. So again, tomorrow, once we go over the homework, I'm going to give you a short test. I'm going to give you only like 10 minutes on it. You don't need any more than 10 minutes. Okay. I mean, if you have to take 12, I mean, what I'm saying is I'm not going to give you an hour to do something that literally is to duplicate this graph. Okay. So that's basically what you're going to have for the quiz. I'll grade it real quick. I'll get it in the grade book real quick. And then what I will do is Monday next week, we have a remote day. Tuesday and Wednesday, we will actually have the quiz, the regular pencil paper quiz, in which I would have handed this quiz, I would have handed this back to you before the end of the period tomorrow. And I would allow you to say, you would be able to see if you made errors on it or you got a 10 out of 10 on it or whatever. You can correct it, then you can bring this piece of paper back on Tuesday or Wednesday, depending upon your cohort, and you could use it on the actual quiz itself. Okay? Deal? All right, so my friends, your homework for next time we have class would be Trig E. And let's say the odds. The odds will be good to go. Don't let this stuff get in front of you. If you come across extra questions, make sure I answer those questions in class live. Okay, but that's what I have for you to do for next time. All right, any questions for me? I'll be right back. If you come up with a question, I'll be right back.